Watch this. I have two chats with an AI about different video projects. One is a past experience, one is this current video. Each chat has completely different context and history. And that's the goal of this preparation. All my chats are powered by this exact same n8n automation. I have one n8n workflow, multiple contexts, and the creation of a new chat is easy. I just have to create a new thread. But if you don't know me, well, hello, my name is Maël Simon. I am a computer science engineer with a specialization in artificial intelligence. Today, you're getting the complete technical breakdown of how to build this multi-context Discord bot system. Before we dive into code, let me show you exactly how this architecture works. Understanding the data flow is critical before building anything. For me, the goal of the automation is to chat with an AI to make my YouTube videos. So I want to have multiple of them in parallel, and I want it to be easy to create new chats because I'm going to keep creating YouTube videos. So I need the creation to be easy and I don't have to mess with any configuration. I watched some n8n videos. He used Telegram, but it's not what I need because it's either you have one conversation and you can use all this Telegram conversation with the AI, but then when you need to make another context, you don't have an easy way to change it. Or it's going to be one message is the order to the AI, but I need again a chat and I didn't find a way with Telegram to do that. So that's why I went for Discord, and it's because of the threads. A thread is like a sub-conversation in a channel. And I went with that because like this, I can set up a Discord bot once for the channel and he's going to have access to all the different threads. So one setup, and then I can create any amount of different discussions I want, all without messing with the configuration. And so here is our system. We're going to have Discord there, and it's going to send the messages to my workflow in n8n. And then n8n is going to, again, send the message back to Discord. But what's happening in n8n? So in n8n, here is our entry point. We're going to preprocess all the data because I can send like text file, I can send audio, or just my messages. And then here is our AI automation. So like I said, you can use whatever you want on that. But for me, I've got like one agent that is an expert in thumbnail, one in title, one in scripts. And I've got a package manager that is going to send the request to everyone. So I've added a little bit of logic so that I can send to either the package manager by default or to one in particular if I want, but that's not the subject of this video. And then once the AI got his answer, we're going to send the response back to Discord using this HTTP request. And here's the trick. Discord threads become your unique identifier. So the bot extracts content from any file type and sends it to n8n with a thread ID. Then n8n processes all the data to make it one message and sends it to the AI. Like that, we have the same workflow that handles all threads, and threads keep context completely isolated. This architecture scales immediately. Quick disclaimer before we build this. I host n8n myself on a VPN through Hostinger. It's not a sponsor, it's just what I use. I'll be using Docker for everything, so my Discord bot and the Postgres database. There are other hosting options for the database and n8n setup, but for the Discord part extraction, I only know how to do this with the Docker server setup. I haven't explored alternatives since Docker covers my need. If you know other ways to handle my Discord bot hosting, drop it in the comments. I'd love to learn something new from you. So let's start building. First step is the Discord bot setup. This bot needs to handle multiple files type and send everything to our webhook. The thing is, I never built a Discord bot before this project. My goal is to go from idea to realization as quickly as possible. So I'm going to show you my process so you can copy me. So basically my process is going to describe my project to Claude, and he's going to give me a step-by-step plan with the code and the different Docker parts. Okay, so what I did there is I talked into my mic for about 3 minutes, and Windows then converted it to text, so it's faster for me to write all the instructions, but I don't think it gives you a lot of value, so I took the final instruction and put it in the descriptions if you want to read it. So yeah, it will go something like that. And then at the end, in general, I like to ask, before proceeding, ask me any clarification questions you have. But right now, I think it's pretty clear, so I won't use it. So right now, it's generating everything I asked him to do. What's going to happen is I will take the code and then paste it and try to debug it, run it, etc. until it works. I've already made it, so I won't do it again. But the process is there. Again, if you have any question or it's missing things or whatever, you can still ask the AI. It's not magical, but it's going to be a great help to accelerate the process. And also, that's literally what I've done. So for Discord, I've never used Discord before, and I just followed the steps that were on screen to create my bot token, to add it to that channel, etc. So it took Claude a few minutes, but here is my Discord bot project setup guide. So with the step-by-step to how to create the Discord bot, then the management, etc., the main code, the bot, the API, models, requirement, Dockerfile, Docker Compose, etc., etc. But you may be asking, why do I use a /generate message instead of just sending a big message, or like each time I send a message, it goes to the AI? Well, it's for two reasons. One, as I said in the description, Discord allows only 2,000 characters, and then there is a limit. You can increase this limit by going with the premium option, but I don't want to. When your message is bigger than 2,000 characters, on desktop, you can convert it to a text message. So that's why we handle text messages. But on mobile, you can't. On the other hand, on mobile, you can send voice messages, and on the desktop, you can't. Or at least I didn't find a way to do that. And lastly, I may want to send images to my AI. So while I'm at it and handling different types of file, just process the images too. So that covers why I have different types of files, but not why I have a command. It's because my AI send me big messages, so I can respond to it part by part. So I send a message, and then I do some other stuff, then I come back again. Because I have 5 minutes, send a message again, and like that until I'm ready to send the whole message back to the AI. And then at this moment, I can do a /generate. But yeah, mainly the command was to overcome the 2,000 characters limit, so that like that I can send multiple messages, and then my bot is going to take all of them and send them to the webhook. Talking of the webhook, let's create it. This is where the Discord data gets sent to n8n for processing. And we'll need this to test and create our workflow. So it's our entry point to that. So you select a webhook, and there you can see there is a test URL and a production URL. This is the one we are going to use to test it. In the HTTP method, we're going to use a post because we send data to it. And then pass authentication and respawn, you can let them as they are. Now that we have our entry point set and that your code is working, it's time to containerize and deploy. I'm going to run you through my configuration. So for the Docker file, I start with the Python 3.11 Slim. I install the system dependencies, then UV. I copy the dependency files and install them using the UV sync. Then we copy the code, create the logs directory, and send the environment variables. And finally, we expose the port, so 8000 in your case, and the command to run the bot. So because I'm running the server and the dependencies are managed through UV, it's UV run Python and the name of my file. For you, it's going to be main probably. For me, it's Discord n8n bot. Then we want to build the image and push it to our Docker Hub. So we are going to build the image and give it a tag. And then we're going to push the image to our Docker Hub. So now my Docker image containing my bots is on my Docker Hub and I can pull it from anywhere. Let's go on my VPS. There I can browse a terminal. On my server, I'm going to make a directory for the Discord bot. Go into it. We can then pull our image, and now we'll have to create our Docker Compose on the server. So here's my configuration. I've got my image, which is the image I just pulled, the container name, restart unless stop, because I want it to restart again and again. I'm going to link the port, so 8000 to 8000. I set the different environment variables, so I need the Discord token, the channel ID, and the n8n webhook URL, the different volumes, and important part, the networks. So on Hostinger, there is a Docker running the n8n service. And this is running on the root default network, at least on my server. So that's why I set the root defaults on the networks and I specify the network's root default external true. It's like that. My image is connecting to the existing network of n8n, and Discord and n8n can connect and talk to each other. So let's take our URL from the test URL of our webhook and put it inside our .env, and then we're going to deploy our Discord bot. Now that it's done, we can listen for test events. So it's going to listen, and once my bot detects something, it's going to send it to this test point. So for that, I'm going to create a new thread called test. I've got one here. So I'm going to create my test there and send a message. So /generate. And here we're going to see that we've got some data. And so here we can see that we've got a list of different messages. Each one got either a content or an attachment. A message can have multiple attachments. And in the attachments, we've got some audio, we've got some text, and we even got some images. And so now we're going to set up the n8n workflow. We'll start with a simple version first, and then we're going to make all the data processing. So starting from the webhook, we're going to create a split out. This is going to turn a list inside items into separate items. Like that, we can process each item individually, and then we're going to merge them all together. So we're going to use the body.messages, and we're going to add a field which is include binary, because we used some audio, text, images, etc., which use binary, so we need to include them. Then we're going to add a switch. The switch will allow us to differentiate between when we've got a content and when we've got attachment files. So here it's the message content. And we're going to add another one, which is the attachment there. And it's an array and it's not empty. If we've got some attachments, then we want to process them. Then from that, we're going to use all the same formats. So I'm going to map it right now, but I'm going to use the same one after we process all the data later. So we take our content and name it text. And then we're going to use our timestamp and call it timestamp. Why do we need a timestamp? It's because like that, we're going to order after that all our messages based on the timestamp, so when they were sent. and it's the order we want to concatenate all of them. After that, we'll have a merge node with 3 inputs, because on the Twitch, we're going to process also the messages, text, and the audio files. So that's why we have 3 inputs. We're going to sort them based on the timestamp. And after that, we're going to concatenate all the strings. The easiest way I have found to concat all the strings is to make a code node, and then here I ask ChatGPT to create me a function in JavaScript that does that. After that, you can input your AI agent. For the source of the prompt, we are going to use the full text instruction, which is what we've put all our text. As you see, like full text instruction, we're going to do that as the prompt. And if you have a system prompt, you can write it here. So here is the example of one of my AI agents. I've got all the system prompt that's pasted in here, and the prompt is what I've got from these instructions. After that, you connect it to a chat model. So for me, I'm using Anthropic. I'm going to use one of them. You create some credentials if you need it, and set the model you need. And the memory, we are going to use the simple memory for now. The simple memory is where we're going to register all the messages that we exchange between the AI model and us. So it's going to be a representation in n8n of our Discord chats. For the session ID, we're going to define it below, and we're going to use a combination of our channel ID with our thread ID. As you can see, it's red. It's because it can't determine which item to use. I don't really know why this is happening, but I suppose it's because we have a list of different messages. But the solution is that if you change the .item to the first parenthesis and close it, it's going to validate it. So you do that on the 2 parts, and now we've got a key that is specific to this thread ID in our channel ID. Also, I know that for my workflow, I'm going to exchange a lot of different messages. One part is because I'm going to send long messages, and my AI is going to send me long messages. And so we are going to split them. And also, I'm just going to make a back and forth. That's the goal of this chat. So we're going to increase the context window length. I've increased mine to 500. And lastly, once the AI made its decision and want to respond to us, we need to do it through an HTTP request, which is going to send our message to an endpoint, which is the endpoint we configure in our code. So again, because we send data, we're going to use a post. For the URL, we're going to use the service name that we used in the Docker Compose, the port, and the endpoint you configured. For me, it's the send message. Authentication, none. Send headers, yes. And we're going to use the accept and application/JSON. We are also going to send the body, and here it's where we are going to paste our value. So quickly, I'm showing you in my code there. You can see that I've got an endpoint on the post, which is /sendMessage, and it accepts as a parameter a Discord message. The Discord message is defined here, so we expect a thread ID, a content, maybe some images, and a tag. The tag is the custom system I've implemented to be able to send a message either to one of my specialized AI agents or to the general. So you can customize this however you want, but for me, I needed this tag. So that's where the names come from. So you will need at least the thread ID and the content. For the thread ID, again, you use the first, otherwise it doesn't work. And so for the content, it's going to be the AI agent output. So take it and it's JSON output. And now if we use the execute step, it's going to send the message in our Discord step. It didn't work for me because I needed the tag as I show you, but I forgot to put it. So now that I put it, I can run the workflow without problem. So let's test that. If I do execute workflow, it's going to use the data that I pinned from the webhook, split, switch, edit, merge, sort, code. I've got my answer and workflow executed successfully. And if I get into the test thread, you can see here that I've got my response. And so here is your first working version. The webhook received Discord data, AI agent processed with simple memory, and the response goes back to the correct thread. But there is a problem coming. The simple memory gets wiped after a few hours. There is no persistence at all. So we'll use a Postgres database to solve that. Again, I've asked Claude what are the different steps I need to do to add my Postgres database to my server. So what I've done is that I took the Docker Compose and pasted it into Claude, then asked it, I want to add a Postgres database to it, what should I do? And he basically just took it and rewrote it with the Postgres database, which is this part there. So we take the latest image from Postgres, we name it n8n Postgres, always restart. For the environment, we're going to read from the .environment the Postgres DB, user and password. We save the data here, the volumes are mounted. We take the ports and then we've got an else check endpoint. Also, it made the n8n depends on the Postgres. And lastly, in the volumes, we added the Postgres data to external true. Also, you're going to need to modify the .env, which is where you're going to add the different variables for the Postgres configuration. So Postgres database, Postgres user, Postgres password, and the port. And it should correspond to the one you've set in the Docker Compose. Now let's modify our AI agent and remove the memory to use a Postgres memories instead. You're going to create a credential, and there for the host, you're going to use Postgres because it's the name of the service in the Docker Compose. For the database, again, you're going to use the one that you configure in the .env. For the user, again, same thing, the one that you've configured inside your .env, and the password again. Maximum number of connection, I've left it to 100, and the rest is by default. You save it and use it inside your credentials. And for the session ID, again, we're going to use the define below and use the same combination of the channel ID and the thread ID. For the table name, let it as is, and for the context window length, again, increase it to 500, something like that. Don't forget to save. And now we've got a persistent memory. So now each Discord thread gets its own persistent conversation history. The memory survive restarts, server change, and everything. The final step is data preprocessing enhancement. So like that, your bot can handle files, but n8n needs to extract the content intelligently. And that's what we've prepared here and that we're going to complete now. We've already made the steps for the content, the basic step, which is the easiest. Now we're going to process the attachments. So for that, because they are encoded in base 64, we need to convert them to a file, to a binary file. So we're going to grab the node convert to file and move base 64 string to file. For the input field, we are going to take the attachments that data, and we're going to put it into the data field. As for the options, for the file name, you can grab it from file name, and for the MIME type, you can grab it for the content type. And now we're going to add a switch node again. The goal of the switch node is to extract the text from the audio or the text file. We're going to have 3 routes. One for the audio, one for the text files, and last one for images. And for all of them, we're going to grab the switch node here and take the content type. Then if it starts with audio /, we know that it's some audio file. If it starts with text, we know that it's a text. And if it starts with image, we know that it's an image. Basic. Don't forget that the string should start with, I forgot it. For the audio, we're going to use an OpenAI node. And there we've got a transcribe a recording, which is what we need. Again, create a credential. The resource is audio. We want to transcribe a recording, and the data come from the data field. You don't have to do anything. And then we want to set it to the same format that we did on the content. So we'll grab the text from the text, and for the timestamp, we're going to use the one that doesn't contain the binary data, so this one, and use the timestamp. Nothing else needed. We're going to put them on the same space. For the text file, we're going to extract from file, and then it's extract from text file. Data, nothing to do there, and again, a set. Again, data here, and we want it to be called text. And for the timestamp, there. And now we can grab our merge node and connect them to the different inputs. Then after that, it goes to a sort. We concatenate everything, AI agent and HTTP request, and it's done. So now your system handles everything. You can upload audio and n8n is going to transcribe it. The text files get content extracted and the images get processed if you want it. All the contents gets added to the thread-specific conversation history in Postgres, and one workflow process any input type while maintaining perfect context separation, which is what we wanted. If you want to master this kind of automation that will save you time, you can go to my community, link in the description. There I have the Timecrafter starter kit. It's completely free and includes the visual blueprint of the different steps to create automation that saves you time, plus a 1-hour masterclass covering everything I wish I knew when starting my LLM journey. You'll learn how LLM works, prompt engineering, AI ethics, and even a live coding demonstration. Plus, there is a hands-on project building AI integrated application. It's the complete guide to LLM-powered automation. Again, the link is in the description, and thank you for watching.